Hello everybody, this is Carmen Killed the Cat, and welcome to your 14th Lua 5.2 tutorial. In this video, we'll be going over the global and local environment tables, so let's get started. So, what the global environment table is we'll start with that, is it's a table that stores the name and values of all the global variables within the program at the time. So, its name is _G, so let's declare some global variables. We'll say A is 10, B is hello, and C equals true. And now we'll create a for loop, generic for loop, so for KV in pairs with the _G table as a parameter, do end, and then we'll just print K and V. So what should happen here is the for loop should print out all of the keys and values of the _G table, and the keys are the names of all the global variables currently in the program, and the values, are all of the values of the global variables in the program. So it's going to print all these global variables out, along with all of the global tables and functions that Lua has, like the pairs function, the IO table, which stores functions like io.read and write. It'll have the print function, it'll have the table library, and a bunch of other stuff. So if we run this, we can see what happens. And that's what happens. So we get global functions like load, select, the OS table. We'll get to that in a later video. Require, we'll get to that in a later video. The set MetaTable global function. And then we even get the _G table itself. So _G is considered a global variable, so it is an element of the _G table, so it's an element of itself. And then we have our B variable and our A variable that we declared, and somewhere in here, right here, we get our C variable. So all the global variables that we declared are in this _G table. So you can do pretty much any operation you can do on variables with the _G table. So you can assign, you can say _G at position A is equal to 10, and then you can use A as a global variable now. So if we were to say print A and run, then we get 10. And you can set it to any value. I guess we'll set it to true. So you can see that it works for any value. You can also print _G at A. So _G at A. And I probably shouldn't have deleted that because now it's going to be nil, but we can replace that. So _G at position A equals 10, and we get 10 again. So you can access and assign and do operations on variables within the _G table just like you can with normal variables. So _G at position A equals 10 is equivalent to just saying A equals 10. So to show the usefulness of the _G table, we're going to create a simple program that will ask the user for input, and then it'll ask them to enter the name of a variable that they want to be printed, and then it will print the value of that variable out for them. So we're going to write it twice, once without the _G table and one with it. So we'll actually create a global variable first. We'll say x equals 10, and then we'll say io.write, enter the name of the variable you want to be printed, and then we'll say index equals io.read. I'm pretty sure I've gone over io.read in a previous video, but in the off chance that I haven't, it just takes input from the user as a string, so it will ask for input from the console here. And now we'll say f equals load string. We're going to use load string to return the variable that the user entered here. So load string return space concatenated with our index string. And now we will print the return value of f. So this program will work, so we can see It asks us for input, enter the name of the variable you want to be printed. We put in x and we get 10. We can rename this variable whatever we want. We can call it number. And if we run the program and we enter number, then we get 10. But if we enter any other value, so now if we say x, then it will be nil, because nil isn't a global variable right now. So this program works. It works just fine. It'll do what you want it to do. But like I said in the function where we went over load string, this is a very expensive function, and you should avoid using it if you don't absolutely have to. And we can avoid using it just by using the _g table. So what we can say is we can say print _g at index. And this is why we named the variable index, because it's being used as an index in the table. So this will do the exact same thing. We give it number, and we get 10. We give it x, and we get nil. And you give it any other value that doesn't already exist, and you'll get nil. So we can see if we entered print, we get the function that stores the reference to the print variable. So this is a much faster way to create this program. You don't have to rely on the load string function, which is very expensive. You can just do it with this, which is just a call to an index of a table, which is almost instant. So this is a much better way to do it. So this is one of the main uses of the _g table. So another thing we can do with the _g table is we can actually change its metatable to change the way that variables in Lua work. So we can say set metatable _g, and then we'll just directly give it a table. We're not going to create a table separately. So what we're going to do here is we're going to change the behavior that causes undeclared variables to be just set to nil by default when they don't exist. So if you remember in an earlier tutorial, I said if you were to say print x where x doesn't exist, you get nil, and really you can just put in a bunch of random letters, and any variable name that doesn't exist will equal nil. This is sometimes useful, but it can also sometimes cause problems. It makes errors with just simple typos in your variable names a lot harder to find. So we can change that behavior if we want. So what we're going to say is we're going to say the __index meta field equals function, and we don't need the table parameter, so we're just going to give it an underscore for that, and v for our index, or I'll actually give it n for our index. And we can end the function down here. So what we're going to do in this function is we're going to say that if we try to access any variable that doesn't currently exist, we're going to throw an error. So we'll call the error function error. We'll say n is not a valid variable name, or actually it is a valid variable name, but n has not yet been declared. So just as a refresher, the _index meta field is called whenever a position in a table that doesn't yet exist is accessed. So that applies to the _g table. If we try to access a global variable that hasn't yet been declared, it won't yet be in the _g table, and any call to a global variable is equivalent to _g at that variable's position, so, or at the name of the variable's position. So if that global variable doesn't exist, then that position in the _g table won't exist. So by default, it'll just give you nil. But now with this _index function, it will give us an error that says variable name has not yet been declared. And we get the variable name with the second parameter of the _index meta field. And remember, the first one is just the table that was accessed. So that's obviously _g in this case, so we really don't need that. So now, if we were to print x where x doesn't exist, we get an error. It says x has not yet been declared. We should put a space here. That's better. So x has not yet been declared. We can do this with any variable name. Again, just a bunch of random letters. And it'll say that that has not yet been declared. So now we've changed one of the fundamental characteristics of Lua, that all variable names are by default nil. And they still are by default nil, but we really can't see that because every time we try to access a nil variable, it'll give us an error. But the program still works normally if we declare x, so we can say x equals 10, and then we get 10 as an output. So as long as you have already declared the global variable, it will work, but if you haven't declared it, it will create the error. So with this MetaTable, you now have to make sure you declare all your variables before you start using them. And now it works again. So the next environment variable we have to go over is the _env variable. And before we go over it, we have to understand a bit more about how Lua compiles code. So any chunk of code in Lua, and a chunk is just a group of code that's compiled and run together. So this entire program right now is a chunk because it's all compiled together. Any chunk in Lua is grouped into a function by the interpreter. So really this code says, or to the interpreter, it says it's an anonymous function that encases all of this code. And then right above this function, we have local _env equals and then some value. And what the _env table does, it's a table that's created here, is it stores all of the variables that have a scope that's more global than the chunk itself. So any variables that would exist within this chunk would be saved in the _env table. And then whenever you try to access one of those quote-unquote global variables, because Lua doesn't actually have global variables with this system, they're all contained within the env table. So every time you want to access these quote-unquote global variables, so say when we say x equals 10 here, what we're actually saying is _env dot x equals 10. So this, well, we might as well just change them all. So _env dot x. This would be, where is it? _env dot _g. And then the n parameter here and the n parameter here would stay the same because they're local to this function, so they're not contained in the _env table. I'll show more on that in a minute. So to the Lua interpreter, this is what this code we had looks like. So again, to Lua, there are no global variables. All variables that are more global than the variables in the chunk you're currently running are seen as _env dot and then that variable. So really the _env variable just stores these quote-unquote global variables. So this is probably pretty confusing right now, so let's create some code that shows it a bit better than that. So if we were to say, create a global variable, call it x equals 10, and then we were to go down here, create a function, we'll call it f and give it a parameter t, and end. And in this function, we were to create, actually we don't even need to create a function when I think about it. So back to the start here, we have a global variable x equals 10, and now let's create some local variables that are local to this chunk. So when the interpreter goes through and encases all this code in a function, an anonymous function, these variables will be local to that function, while the x variable can be seen throughout the whole program. So we'll say local y is 1, and local z is 2, and then we'll create another global variable, a is 5. So now, if we loop through all the variables in the _env table, because we don't have to declare it ourselves, it already exists, it's just put right on top of the function that is wrapped around this code. So if we were to say for kv in pairs _env and do end, and then we print k and v. So it's pretty much the same code we have for printing out all the variables in the _g table. So when we run this code, if we had _g here, what we would see is we would see all of the variables in the program, so x, y, z, a, and all the global functions. But with the _env table, we only get the variables that are more global than the chunk that's being run itself. So we have this chunk, and the x variable is quote-unquote global, so it will be stored inside the env table, as will the a variable, which is global, and as will this chunk itself, although it won't be seen since it's anonymous. But these two local variables won't be stored within the _env table because they're local to the chunk, and therefore they're not stored in this up value. So to prove this, let's run it. And now let's search for our variables. So we get the same thing we get with the _g table. We get all the global functions, and we actually get the _g table itself. And we also get our global a equals 5, our global x equals 10, but you'll notice that we don't have the y or z variables in here, and that's because they're local to this chunk, so they're not stored in the _env table. And again, we could rewrite this code to make it more like what the interpreter sees as _env.a, _env.x, and then k and v are local implicitly because they're parameters for a for loop, and y and z are local because we explicitly declare them as local, so none of those variables are stored in our _env table. And you'll also notice that k and v aren't in the _env table as well. So again, just to recap, the _env variable stores all variables that have a higher scope or are more global than the chunk that's currently being run, which is different from the _g variable in that the _g variable stores all of the global variables within the program. So I think I said before that if we were to print all the values in _g here, then _g would contain the local y and z variables. That's wrong, sorry. What would actually happen is they would be the exact same outputs in this case, but with the _env variable, if we were to have a chunk that had a higher scope than this chunk that's being run right here, and that higher chunk had local variables in it, they would be stored in the _env table, but they would not be stored in the _g table because they're not technically global, quote unquote, but they are in a higher scope than this chunk that's being run here, so they would be stored in the _env table, but again, not the _g table. So I know that's confusing, but it doesn't really matter too much, and as you use the env and _g, it'll become more clear to you what each one does and how they're different. So now let's move on to some things we can do with the _env table. So we can get rid of this. So in most programming languages, if you have a variable, we'll say a variable x, that has some scope, and then in a lower scope, so a more restrictive scope, you create a local variable with the same name. So we create a new x that's local with x equals 1. So this x is global, and this x is local to our chunk. Now, in almost all programming languages, if you try to use the variable x, so we'll just print it out here. If we print x, in almost all programming languages, the compiler or interpreter will choose the most local form of this variable. So when we try to print x, it'll choose the most local form of x, which is 1. So if we run this and go up here, we get 1. But notice that we have an x that's stored as 10 in our _env variable. That's our global x. And we can use that. We can say print _env.x. We can use this to print the more global form of x. So if we run this, then we get 1 and then new line 10. So the 1 is from our local x, and the 10 is from our global x. So you can use the _env variable to access more global forms of variables that have been overridden by local forms. You can also use the _env variable to hide global variables. So we can get rid of this, and we can go to the top of the chunk and say _env equals empty table. So before this chunk started, before it was encapsulated into a function, the line _env equals some value was run. So after that line, the _env table contains all of the variables that are more global than the chunk. But now, as soon as the chunk starts, we set _env to an empty table. So all of those values are gone now. So now the _env table contains nothing, and we're kind of starting from scratch. So none of the global variables from before this chunk exists. So if we try to run this now, we get an error. So error Lua line 6, attempt to call global pairs, a nil value. So we got an error when we tried to call this global function pairs, because to this chunk now, there is no global function pairs, because all the global variables were deleted from the view of this chunk. They can't see it, so if the program were to keep running, it would create another error with print, because print's also global, so it was deleted, so print no longer exists to this chunk. And if we were to call any other global functions, variables, tables, or anything, it would create an error because the chunk doesn't see them as existing. And this can be useful if you want to restrict access to some parts of your program in a chunk, but it can also be useful to be able to access them just in a more restricted way or a more explicit way. And if we wanted to just be able to access the global variables, say by having to give them a separate name within a table, so instead of just being able to say pairs, we'd have to say g.pairs. We could do this. We could say g equals underscore g, because the underscore g variable still exists before we set underscore env to empty table. So now we still get the error if we run it, but we can say g.pairs, not comma, g.pairs and g.print, and now the program runs like it did before. So we get x equals 10, or you can see here, since the only thing we're printing is all of the values in env, the only values left in env are x, which is 10, and g, which is a table that contains all of the old global variables. So if we were to loop through and print out all the values in g, then we get all our old values. So now we've really just restricted the access of all the global variables to a more explicit way of accessing them. And if you wanted to, you could say underscore g equals underscore g. And this looks really weird, I know, but it's actually valid. What we're doing is we're saying empty out the env table, but set the member underscore g, or the index underscore g, it's not a class, it's a table, to this old underscore g value, which does technically still exist before this line is run. And that's kind of confusing, I know, but just know that this is valid. So now we can still say underscore g.pairs and underscore g.print, and it will work the same way. But again, the only thing in the underscore env table is our global variable x and our global underscore g, which we allowed the underscore env table to keep. So we can also manually create new versions of underscore env that exist within the same chunk, but in a more local scope. So if we were to create a function, we'll say function f of x, doesn't really matter. I don't think we're going to end up using the parameter. So function f of x, and we say local underscore env equals empty table, and we can actually get rid of this local x as 1. So local underscore env equals, and we'll say x is 50. So now, if we were to print x here, so we'll print x, and up here we will print x, and then after this function, we'll call the function, first off. We didn't use a parameter, it doesn't matter what we put here. And then after we call the function, we will print x again. So it's a lot of printing x. So when we create a new local underscore env variable, it creates a new environment for this little subscope. So, and it's not really a subscope, it's just a normal scope. But it creates a new environment within the same chunk, but the environment only exists within the scope within the chunk. So this local environment will only exist within this function call. So we have the new underscore env variable that stores a different value for this x, and that will take precedence over the global x that we have in the underscore env that controls the whole chunk. So when we print x here, it will print this x, but when we print x here and here, this version of the underscore env table doesn't exist, so it will print this x, and we can just show that by running it. We get, oh, I see. We need to say print equals print here just so that we have the global print variable. Now if we run this, we get 10, 1, and 10. So up here, x is 10, and this global x is stored within the _env variable for this whole chunk. And when we print it, we get our x value 10. But then within this local function here, we can actually make this a local function. So within this local function here, we create a new _env, and we just preserve print within it, and we also create a new x value that's set to 50. So now any global access, or any access to a quote-unquote global variable within this function, we'll try to access it from this _env table rather than the one for the entire chunk. So when we print x, we get 50. Actually, we got 1. Oh, it's because that's because we're this is more local than this. So we should probably just get rid of this parameter completely. So now if we run this, we get 50. A parameter to a function is considered more local than anything in the _env table, even if that _env table is created within the function. So now when we print x, we're accessing this _env table rather than the one for the whole chunk, and that gives us our x value 50. Then we call the function to print that out, and then, since the function ends and this env table goes out of scope, when we try to access a global variable here, we're now accessing the _env table for the whole chunk, and we get our value of x10 for this, we'll call it global x. So that's just another thing you can do with _env. The last thing we're going to do is we're going to go over using environments with the load and load file commands. And we're only going to have examples for load because load file works the exact same way as load, except it uses a file instead of just a string. Oh, and by the way, I think I might have used the load string function like this, and that's a Lua 5.1 function. It still works in Lua 5.2, but it's been replaced by load in Lua 5.2. So if I use that, I'm sorry, use load instead. It works the exact same way, except it gives us a bit more functionality, which I'm about to go over. So, back to the point, we still have our global x variable here, and if we were to load some user-generated code with the load function, so say that we got input from the user, and the user entered x equals 20. So now we will print x. So, like I said before, I think I said this in the load tutorial, or whatever tutorial we went over load in. This code here is compiled as a separate chunk. That's why the function is so expensive to run. So when we create this, a new _env variable is created, and that _env variable contains all of the variables that are above this chunk that's being compiled here, but it also contains the variables that are compiled within this chunk. So our x equals 10, this global x, is in the _env variable that this chunk uses right here. So when we change x to 20, it's changing this global x to 20 throughout the whole program. So if we run this, we have to call load. We'll do it like this. It's just kind of shorthand since load returns a function, and we're just calling the function it returns. It's unsafe, but you can do it, and we know this function will succeed. So now we get 20, because this chunk that was compiled right here changed our global x to 20. Now, usually this isn't a problem, but if you're reading files from a user, then the user could be trying to mess up your program, and you don't want that. So there is a way to make it so that you can check what's happened in the file before, or the file or the string, before you allow it to affect your environment variable. And to do that, we give the load function a new environment that it will save its variable, that it will save its changes to. So create env equals empty table, and load also has an optional second parameter that is the mode we're going to read it in, but we'll just give it the default, which is bt, which means read binary and text chunks. It doesn't matter what that means. We may go over it later, but it doesn't matter that much. You'll almost always use bt. There's no reason to use anything else. And now, as the optional third parameter, we give it the environment we wanted to store its variables in. So we'll give it env. So now if we run this, we get, alright, I figured out the problem. There's actually another parameter that we have to give here that I didn't know about. It's called source, and it's just the source of the chunk that for any error messages or debug information. Doesn't matter at all to us, so just put an underscore here. And the underscore is just, it's a convention in Lua, which means doesn't matter. So now we're calling the load function, we're creating the chunk x equals 20, these two parameters don't matter, and we're saving all changes to the environment in this temporary, actually let's make this local, just for the purposes of this tutorial. We're saving all changes that this chunk makes to this temporary env variable, rather than this chunk's environment variable. So now, if we run this, x is still 10 after we forgot to call the function. X is still 10 after we call the chunk that load creates. But if we were to print env.x and run it, we get 20. So all changes that that this load chunk created are all changes that this load chunk made are saved in this env table rather than the underscore env table for this entire chunk. And if you wanted to, say, do some checks with this env table, and then if everything was okay, then you would save all the variables within env to their respective variables in underscore env for the chunk. Then you could just say for kv in pairs env do, and then underscore env at k equals v, and end. And that will just copy all of the values in the env into the environment variable for this chunk, once you've checked and made sure everything's okay. So that's another interesting thing you can do with environments with the load function. So that's all for this video, and I know this was probably a pretty confusing video. This is a pretty confusing topic, but for most of you, you'll never end up using this. You don't use it much, it's not that useful, and really this entire system was created so that you don't have to use it. It's to make it seem like Lua's system of local and global variables is just like any other programming language's system. It makes the quote-unquote global variables appear actually global, and local variables appear actually local. And local variables are actually local, but global variables aren't really global. But this system makes them seem global, so you'll never really have to use it, especially not the underscore G table. I showed you the few useful ways you can use the underscore env table, and you can use those if you need to, but in most cases you'll never have to use either the underscore env table or the underscore G table. I'd say the most useful way to use either of them is this right here, where you create a new temporary environment to store changes made with the load and load file functions. That's actually pretty useful, but other than that, there's not really much use in either of these tables. So don't worry about this video too much. It is good to know, but you won't end up using it again very much. So in the next video, we're going to be going over modules, which is similar to the include preprocessor command in C++ and C, import in Java, using in C#, and so on for other programming languages. It's another way to read Lua code from other files. So I'll see you then.